Sven, you want to share your comment with us?
Yeah, this is Sven Karlsson from DTU. So I'm actually one of those that were there when OpenMP started very many years ago, and I think I was one of the very first persons implementing an OpenMP compiler outside the major vendors. So what I noticed is that over the years, these kind of problems with outlining seems to be popping up as OpenMP matures in different infrastructures, right? So it used to be that in the academia, when we did the source compilers, which were the first ones in academia, essentially the vendors were laughing at us because we didn't get it right, and then we got it right. And I do remember that the first versions of ISC, when they tried to start implementing OP, they did get it wrong, right? And I seem to see now that people keeps repeating these mistakes in how you outline and how you move information between the parser and the optimizer. Is this something that we keep repeating the history? Is this something that we need to start looking into, how we actually are progressing information from the front end to the back end in a more structural way? And I think here we have great people such as Eyal Sachs, who knows a lot more about compilers than I do, but I think this is a discussion that can be had, because I think in any all compiler workshop or conference I've been at, there's always been one or two issues about how do we make sure that when we do major transformations that outlining is, how do we make sure that we are not changing the information flow in the compiler to such extent that we lose information that's useful for optimization. And I'm sure that a lot more smarter people than I here can chime in and discuss this.
So if I can comment on that, yes, I mean, outlining is definitely part of the issue. And I don't think we have completely pushed the boundaries of what kind of information we can push through outlining to be able to have more optimization. So I think there is work to be done there. And there is work being done right now in the LLVM compiler. But yeah, I mean, it's a valid question whether we want to change the paradigm completely if there is something better to replace it.
I mean, I see this as a multifaceted discussion, right? So one thing is, are we doing the right thing by doing outline? I think outlining is used in so many different situations that it makes sense. The second is there something more profound here? Is there something that actually rather relates to compiler theory and the way we should express optimization? I think one of the issues I had early on, this was 99, when we were writing source compilers, is how do we actually make sure that optimization controlling pragmas were properly passed on through the front end back to the over to the backend compiler. Of course, this is a major impact, let's say, on if you want to do any kind of vectorization and anything like that in backend, right? So I think, is there something we need to start addressing more fundamentally?
Maybe. So maybe we start to open this up a little bit. We are supposed to go into our Q&A Ask Us Anything session. And let me just thank Jorgis again for this talk, and then he can continue to answer the question. But I think this is a good kind of entry point into more generic Q&A. Thanks, Jorgis. And if you want, you can give a comment on that last comment by Sven.
I mean, in general, I think I agree with Sven that it's a good thing to look more deeply and try to research more deeply on how parallelism is actually compiled using our compiler. So outlining is definitely a solution that works technically. And as I said, I don't think we have pushed the boundaries on getting as much performance as we can by using this technique for representing parallelism. But I think it's definitely an interesting area of research to look what are the alternatives. I know there are a lot of efforts in defining some kind of parallel IR or embedding this more in the compiler. But it looks like that most of those methods were not exactly fruitful or very very impactful to be able to dethrone outlining as the method of choice as of now. I know there are interesting efforts that are being done, and the MLIR actually is a very interesting way to look at representing programs and creating intermediate IRs and optimizing like that. But yeah, I mean, I think it's a very, very valid, very nice question. It's an open question. I think it needs research.
To add to this on, like there were two parts in Sven's comment. One is like pragmas that have to be piped down through the pipeline to, let's say, the vectorizer or the backend. And to this day, LLVM is still trying to determine how to do that best. We're in especially Michael Kruse, who's probably online, is working on this and making that more reliable, because if you start to annotate your loops with pragmas and you want your optimizations to like consume those, but those optimizations are way later in your pipeline, everything in between has to somehow preserve that information, which now gets tricky. What happens if because these optimizations change things? So how do kind of changes interact with the annotations that you had initially with the pragma? So if you unroll a loop, what do you do with the vectorizer annotations, for example? So questions like that are certainly not fully understood yet, but we're actively working on that, as we are actively working on actually optimizing through outlining right now.
And it was just a comment because, as you said, we OpenMP programmers are lazy, so shared variables are easy. And as you also pointed out, why should the loop boundaries be shared if this causes problems? But if I go back to a compiler that I used for many years and I still use in teaching, even though it's discontinued from the vendor, it has an autoscoping feature, which is really nice because it tells me, hey, you're doing something wrong, or maybe you could do something better. The compiler does an analysis of your loop anyway. So the compiler should know which variable is good for being private, first private, shared, and so on. Okay,
Agreed.
Over time, OpenMP standard has developed and it's more complicated now with new pragmas and target and all that. But for the basic things like loops and vectorization, I think this is still applicable. So, and I just see there's a comment from HPE, I guess Cray, that this product still exists.
So in addition to the vendor compiler that can do something like that for you, even LLVM right now, if you download the newest version and turn on optimization remarks for the OpenMP optimizer, you will be told if shared variables are most likely to be or should be first private. So these remarks are already inside LLVM as we speak. And LLVM has close to support to actually just do the transformation for you. So even if you don't like ask for the remarks and look at them and act on them, LLVM will just like take what you gave it and do the transformation from shared to first private or from first private to private for you if it determines that is legal. So okay. Very much like as you said, and that is obviously what you want to get at. So on the other hand side, my comment earlier was we kind of missed the opportunity to teach people the right thing in the very beginning. And now we have to kind of deal with the fact that codes have this implicit shared variable behavior. But we should do it automatically. I totally agree.
Okay, so I need to jump in, given that I was part of the initial OpenP standardization effort. At that time, having the automatic shared in C was a very sound decision made, I think. That caused some problems later on, but there are also other parts of OpenMP that caused the problems later on. But there were plenty of very smart people arguing for why it should be like that.
Interestingly, it's not the same in Fortran, right?
No, Fortran is not shared by default. It's private by default.
And
that was also for a reason.
Interestingly, it's only shared in C in parallel, but not in task, because later on people said, let's not repeat that.
Yeah, I know. I'm just saying that this what my point I'm trying to make was that this was actually discussed, right? Should it be shared or should it be private? And there were plenty of very good arguments for why it should be shared and why it should be shared in C and not in Fortran.
I also believe that.
But that's more anecdotal, of course.
Okay, so Yi, you wanted to say something?
I just want to say that I don't want to write a long list of private, shared, all those things. I want to write a minimum in the source code. Then, because all the private, first private, I have the parallel scenario, has some parallel aspect, and I need to treat specifically. That's why I'm willing to write it. Then I'm also not willing to write all the shared. So that's why I still prefer it shared by default. And I rely on you guys to, if you compiler analysis can't figure out this, could be first private, just do it silently, don't tell me.
That's fair. Okay, so do we have other questions? Anyone? Any question whatsoever is fine. Something you always wanted to know?
Okay,
yes.
so then again, I'm going to bite here because I tend to introduce myself. Hi, I'm Sven. I have a big mouth and I'm not afraid to use it. One thing that has been discussed over the years, right? So I jumped in compilers sometime in the 80s and built some of them myself, and I've been engaged in GCC and also in LLVM development. So one thing that has been discussed over years is the notion is discussion: should LLVM have a high-level intermediate representation, right? And I think we all listened to Chris when he discussed some of these aspects during the PLI Ask Me Anything session the other week, when he actually mentioned that this is might have been a mistake. And I'm thinking here perhaps that in particular for parallelism and in particular for more advanced forms of vectorization, perhaps not a full-blown high-level representation, but at least some kind of skeleton high-level representation could be useful. This may make it possible to more structurally reason about parallelism and some of the issues, for example, that we noticed here still exist, right?
Right. That is certainly true.
So I think this is, Georges again. So I think this is a little bit what MLIR is trying to do. Like they try to create higher level of abstractions that you should be able to use to describe different things in code, and one of those things could be parallelism. I think that's an interesting experiment to see how this is gonna go. I'm not exactly 100% sure how optimizations are gonna be able to be done, because the way I understand MLIR works is that it has these distinct intermediate representations that optimizations cannot propagate through the different layers. So I'm not sure how this is gonna work in terms of optimizing whatever you use to describe OpenMP, the OpenMP dialect, and the underlying LLVM code in conjunction.
Last I talked to Albert, he mentioned that concurrency and parallelism may not be fully there in MLR yet. Is this being worked on? Is it out yet, or what's going on there?
Kiran.
Specifically about the OpenMP dialect, then it's still it's a work in progress only, and we are specifically concentrating on the OpenMP properties rather than a general form of parallelism.
Do you know what the status of the GPU dialect is?
No, I don't know, but there is some progress there, and yeah, it can launch. You can launch parallel code, but I'm not closely following it.
Okay. As far as I know, there is no kind of threading alternative, like a pthread-like overlay. Alistair.
All right, yeah, I'm just gonna kind of read my question here. So I've had some experience with various HPC compilers, and most of them do not give good feedback for like, did this optimization happen? Did it not? Stuff like that. And so like that would be like super helpful for lots of people. Like, disclaimer, I'm not old enough to actually have used vector compilers back in the day, but like I've heard tales of how great they were with their feedback. And so like kind of what's going on in LLVM and especially in MLIR to support like better compiler feedback for users to optimize their code.
Yogis, that might be something you can chime in for the the LLVM side. You've worked with the remarks the most, right?
Yeah. Oh, I was muted. Okay. All right. Yes. So there is an effort in LLVM that it outputs optimization remarks, and basically those give you this information per source file and per source line in the file. Sometimes this information can be a little bit cryptic when someone looks at it, because they need to be familiar with the compiler optimizations. And also another problem that we saw when we were developing our framework was that you get this information very fragmented. So you have different remark files for different files, and then it's kind of hard to go through all those if you have like a big application. And that was also why we did this combining thing by putting all these two together. I think it, and then again, there are the tools that visualize this information that are very important as well. So there are a couple of tools in the LLVM toolchain, like the opt viewer, that can do that to create the HTML outputs. And those are useful in the sense that you can get a lot of information out by looking through your browser on what is happening. But looking at this as a developer, more like at the compiler side and less on the application side, I can still feel that it's hard to parse information, it's hard to understand information, and it's hard to translate on what do I need to do to get my code better. So I think there is a missing link here that we would like to work on and help with that. And another thing which is interesting is that the LLVM remarks, they are actually becoming better, specifically to OpenMP right now. So they are being extended to include information on how OpenMP transformations and how OpenMP optimization is changing code, or how it's missing optimization, which is also very good information besides what kind of optimization applied. Actually, it could be more useful. So yeah, I mean, I know that from the LLVM side, Johannes can add things.
No, I was hoping that someone else might want to chime in. I see a couple of core developers here. Maybe someone has an opinion on our remarks inside IR or MLIR.
Michael here from Argonne. Some remarks. I think this is an inherently different problem because you need to understand what the compiler has done so far. So lots of the optimizations only uncover after some other optimizations and has transformed your original code. You see this when you try to debug optimized code, that the breakpoints you're setting don't seem to make a lot of sense. I now remember on the LLVM mailing list, there was at some point a suggestion to like, when emitting such optimization remarks, also emit the history of where this instruction comes from. And that suggestion was especially tracking inlining, telling, hey, you have multiple instances of this function inline into multiple functions, and I'm specifically talking about this instance from the function. Problem is, it is harder to track. You could like add metadata, additional metadata for each instruction, which follows the history of which where the instruction comes from, after inlining, after loop invariant code motion, and so on, and emit it like a compiler would emit like the history of template instantiation if you're in a template, or the macro expansions when you're in a macro. But I think this comes with a lot of overhead there, while possible. I'm also not sure whether for the average user it's helping that much, since average user think, hey, I want to have vector code, but why does this thing tell me about phi instructions? So I'm not sure whether we can expect the average user to understand everything that's going on inside the compiler.
Sven, you want to comment on that?
Yeah, I have a comment. So a couple of years back, Alan Sachs and me and a couple of other, and in particular, some of our very, very talented students, put together a tool that took the optimization comments that were available at the time. We actually, in the first version, had to implement our own optimization comments into GCC because there weren't any. And then we tried to build a tool that will allow feedback to users. Some of the key highlights from that work was that it is extremely hard, much more harder than we thought it was, but then again, we are not smart enough, to filter the comments in a way that's useful to the average user. I think this is still the case today, that optimization options are ideal for users who either are adept at compilers or are actively writing the code. But we also have a lot of users who are confronted with large code bases, and they need to get around in them, and they need to optimize them. I think this is particularly true in HPC, where we see code bases surviving over many, many years. And here is the challenge: how do we pick the 5 most important problems or comments to feed back to the user, and how do we prioritize that so that it actually can be fed back to an IDE?
Yeah, I was going to comment, but I don't have anything on top of what Sven just said. It's basically a really interesting area of exploration to find out where and how we want to communicate information back up to the users, or even back up to compiler developers, so that we can find out, say, across a larger code base, where the areas that we're missing optimizations, especially in hot code. So it's really hard to provide useful feedback, but I think it's also a very worthwhile exercise to at least try to do something more than what we've got right now.
I agree. I think that also timing is right to return to this work. I mean, there were a couple of efforts to this end, I think 10 years ago, something like that now, and I think it's worth to return to them now.
Hi folks, I've got one thing to add to that. This is Will Lovett at ARM. We've started using LLVM opt reports in our commercial compiler, and I think exactly what Sven says is correct. One thing that would help, like we've said, it's very hard to know what users care about, but it's not that hard to find the remarks that users almost certainly don't care about, on the grounds that if you look at it through the lens of, does this remark tell an average user something that they can action or they can change the code to do something with? And if it doesn't, then it serves a purpose for compiler developers, and that's fine. But if we can try to separate those, at least that class of noise effectively out of the way, then remarks become more useful to some extent immediately.
Yeah, I think the remark system we're building inside LLVM is verbose and developer centric, and I guess it has to be to some extent, because it is very low level, but there has to be a tooling on top that makes it less verbose and friendly for end users. because it's unrealistic to maintain 2 remark systems. It's also like we barely managed to have one. And
I certainly don't think it should be a different infrastructure for sure. There's a danger there of, if it's a tooling on top, then if a user says, give me all the remarks that you have because I don't know what I want to know. If you're doing that for a large compilation, you end up with an awful lot of text, and it uses a surprisingly large amount of space to store all of that. It feels like there should be at least a first filter we can apply that will take away some of the stuff that general users might not care about.
It might be true. What we usually do there is we have kind of an all and an all hidden flag. So like a really all flag. So the first version is the user-facing one that is like, yes, this is all we know. And the second version is the one that is, if you know what to ask, you get really all the output.
And I think that's the problem at the moment, is that at the moment, you get the know really everything answer.
That's fair, yes. Yeah.
I was wondering why a developer would worry about getting all the warning message, because my understanding is for users, code users, not code developers, they don't need any warning. They don't want to see any warning. For application developers, they have tons of ways to look at specific source code and get all the warnings. So we can tweak the CMake or do whatever we want to narrow down the information we need to collect. So for compilers, you just provide all and then individual control knobs. That's sufficient, I would say. You don't need to worry about 10 lines or 100 lines. Just get me all the relevant ones.
Canada, you want to talk?
Sure. Can you hear me?
Yes.
Okay. On a complete not backend change of subject, at Sandia, we have people that want Clang Tidy plugins for ease of use and/or because they want to put, secure, protected things they can't put in the public into their plugin. My question is there a reason this doesn't exist? As in, is it like very difficult to do it? Or is it just no one has spent the time to do it? And if the latter, then how would one start the process of trying to implement this?
As far as I know, I'm not actually on our team that deals with that, but as far as I know, it's not impossible to do. It's just that no one has. A lot of the Clang Tidy stuff has been specifically for, things here and there. It's also fairly easy just to patch it. If you wanted to add a plugin infrastructure to it, probably the easiest way would be to start a discussion upstream with and add in the various developers for Clang Tidy onto it to make sure. Just a simple RFC will do of like, hey, I'd like to add a plugin infrastructure because we have some specific things that aren't really applicable to anyone else, contrary to other existing plugins or whatever, and we just want to add this. Do you have any, was that enough for you? Would you like more?
Yeah,
you can always send me email too if you want to.
So it's as simple as just emailing like Clang Dev and with an RFC?
Yeah, basically. I don't know that there's a special tooling dev mailing list. So
no, just use the standard CFE dev. It should be
CFE dev works in. Yeah.
Okay, and if I have trouble getting my messages to appear in CFE dev, who do I contact about that?
You need to be on the mailing list to do that. For what it's worth, you need to be subscribed.
So I've tried to get subscribed. My messages don't go through. I've emailed Tanya about it, but I'm guessing she's very busy, and that didn't go through either.
Check your spam folder.
Yeah.
The registration subscription emails from those lists always go into the spam for everyone. I have no idea. It's really bad.
Okay. I will attempt again, and thanks for the advice.
And try Anton if nothing else works.
Yeah, right. So sometimes the, as far as we saw, the mailing systems in different companies simply just filtered out all these emails, even not putting them into the spam folder. So, yeah. But in any case, the first message is typically should go through the moderation queue, and we're relying on the volunteers to moderate the emails. But usually this thing works pretty well, so the delay from getting the first email is not very big, maybe a day or so.
Because I have submitted 2 emails in the past that just haven't ever made it to the actual list. Okay, well, at least now I know someone to poke if that doesn't, if that happens again.
Anton can unblock you. Yeah, so Yi, you wanted to ask a question or start a discussion?
So 2 questions. One is since we have also the other data parallel type of thing, like the SQL thing, it's like how much the OpenMP analysis can share infrastructure with these parts. I'm thinking of like OMP loop, if you need to implement. It's kind of data parallel like thing. So I'm not a compiler developer. I'm just throwing random questions. If it's not feasible at all, just tell me. It's fine. The second question will be interoperability, because OpenMP is not the only threading model we use, even just within the C++ code, right? We could have the standard library threads. Then when we have GPU, we have the GPU runtime. So we could not just have one monolithic OpenMP to deal all with these. So it's not a really question. Any comments or people thinking about interop between all these components? Handle it smoothly, right? For my limit knowledge for STD threads, okay, then I would ask, yeah, how the affinity plays with each other, or all sorts kind of things. That's my 2 questions.
Yitro, you want to answer?
Yeah, so we had some experience in, I work for IBM, and we had some experience not in LLVM, but because we have been working on the Excel compiler support for OpenMP, and the GPU that we were using for offloading code is NVIDIA-based GPU. So the question was, some people wanted to have support across different languages, Fortran, C++, using OpenMP, and also using either CUDA-C or CUDA Fortran across all these languages. So of course, that helped the fact that on the GPU, they all follow the same object model. So as long as you abide to the CUDA object model, you can actually exchange objects and link them and use the same tools to do either debugging or performance analysis. But in general, we have taken the approach of not mixing, for example, CUDA Fortran language constant or region in the same section of the code that use OpenMP, to try to keep them separate, with some leeway for sharing things like allocated memory done through via CUDA Fortran, and then having a pointer and mapping that pointer in our OpenMP region and so on. The thing is that the language itself, like OpenMP is an extension language specification, they don't really take into account interoperability with other languages. And so approaches that are taken are going to be kind of ad hoc. There isn't really something that is going to scale or be consistent across different architecture vendors and so on. So I think that is achievable to have some level of interoperability, but yeah, I don't see that you'll be able to implement interoperability across every single language that does data parallel operations.
So OpenMP is moving towards interoperability. We started introducing some constructs like interop and target variant, which sort of enables you to interact with the native, whatever the native can do, but ability to be able to interact with OpenMP, like OpenMP will create all the queues and all that, and then native object can use that to offload to that queue. So there is ability to do that. And for us, like DPC++ and OpenMP, they can both exist in the same program. Although right now we don't have the ability to share data between them, but they can all both work together in the same program. You could use some kernels to offload to a GPU using DPC++, or you could use OpenMP.
Yeah, that's a question of the difference between coexistence and integration. Like coexistence, like you said, it's more like you can have different section of the code or different objects, different files that use different programming model, and they don't exchange data with each other. That's one level of what I would say interoperability. It's more like coexist. And the other is more integration, where you can actually exchange data across different programming models, and that's a lot more challenging.
Right, and so we have taken that step towards providing that interop object, right, which lets you, gives you the ability to share the device queues and devices and all that. So that's coming in 5.1.
Exactly. And with regards to, like, anyone wants to comment on the SYCL and OpenMP optimization sharing capabilities? I can, but I wanted to maybe let Intel folks like Ravi say something more.
No, you go ahead.
Yeah. So with regards to optimizations, there's currently like two things going on in LLVM. One is a very generic approach that we will optimize OpenMP programs. For example, we do this shared variables to first private variables transformation. Actually, this transformation is not aware of OpenMP whatsoever. It is a very generic approach to optimize indirections in programs. So literally, we teach LLVM how to deal with the indirections that OpenMP introduced, because those interactions are introduced by other paradigms as well, mostly parallelism paradigms. Like the way OpenMP is implemented in the compiler level is the same as pthreads is implemented. And if you look at all the other runtimes, take any parallelism language you want, at the end of the day, all of them look like that. So where you have these callbacks and these runtime calls, and that kind of interface is what we taught LLVM now to optimize. So we get some sharing there for sure. So we get like the basic transformations for all of them. Then there is the second level, which is parallelism specific optimization. So what to do there. And then at the current rate, we're working towards optimizing OpenMP specifically, at least in upstream LLVM. There was initial, like which we wanted, and we looked into a more generic way to do things. And eventually we hope to generalize these things, but it's not that trivial to generalize across parallelism semantics, because all of them have subtle differences, and you kind of have to be aware of them. It's not like if you just have really data parallel do all for loops, you're fine. But as soon as you go in any direction and like some special cases here, or like you have to be careful there, or certain things are different, you have to start to build abstraction layers, interfaces. What kind of properties can you assume and can you take? And the idea now was to start with OpenMP and then have some optimizations that we can generalize, instead of trying to design this generic thing that we don't really know where it's heading, and then try to kind of apply that after the fact.
I always felt that there must be some kind of level of high-level intermediate language representation that can be used to do common optimization between data parallel languages or so on. As long, and that, it would be great if, for example, talking about OpenMP, the OpenMP front end were to go and express this kind of parallelism construct in MLIR, and then this optimization were done at perhaps at the MLIR level. I don't think that optimization, as you lower the IR down to closer to the target accelerator, the type of optimization they're going to be doing are going to be necessarily more close to the hardware than the language. And there, the type, the amount of reuse between optimization may diminish and may become more specialized, just like for different backend, like PowerPC backend, Intel backend, the kind of codegen that you do is different. But at the high level, there is probably still opportunity to do something, inside MLIR to optimize these data parallel constructs.
There is for sure opportunities to start doing optimizations, given that right now, at least LLVM upstream doesn't do any. So there's a lot of potential. So Yi, you wanted to comment on that?
Sorry. Thanks you all giving ideas and giving fair answers. That's my comment.
Very good. Do we have another question or discussion topic? Otherwise, I'm going to ask one that might be what might be interesting for both kind of users and developers, because we have a very mixed pool of participants in here. So what I thought of, what I would ask people in a crowd like this is, what feature that LLVM is currently working on to some extent are people looking for the most? Like what is the one thing people are wanting to have that we are not having yet, or we were waiting for a while?
I strongly need a proper vectorizer, which at least on Intel, it needs to compete with Intel compiler. So the vectorization.
Okay, very good. Better vectorizer. What are people looking for? And also asking developers that might be eager to see features that were started years ago to be done at some point.
Yeah, I was also looking for, I'm not fully tracked. I saw like for power system, they were also doing some vectorization work, but my record was it's not finished yet.
Nick?
Sure. You probably heard me rant about this before, but of course, Fortran with OpenMP target support, which I know we've made a lot of progress on it, getting the Fortran in there this year, but it'll be much more useful once we get OpenMP target support into Fortran, and an actual driver, of course, connected to a backend.
Yeah. So waiting for F18 to be production quality, huh?
Yeah. I think the options for Fortran are pretty limited, and I think people would jump at the chance to use F18 in a production environment, even if it's only for NVIDIA GPUs. It would be a good yeah. Anyhow.
That makes sense. Cool.
Yeah, maybe this came up a bit before too, but the interop objects, that there's a clean way from OpenMP of calling vendor math libraries in a consistent way that's not too different across different vendors.
Yeah. People seem to want that. I see multiple comments about OpenMP targets done right. Alistair, Sven, do you want to explain what done right means?
I can jump in. I'm afraid to do that. I think if I look across different implementations, I'm not only talking about LLVM, but I think we also transcend LLVM here a little bit in discussion. I see a wide range of different implementations and capabilities. And I think we all agree that we are heading toward extreme heterogeneity. So I think for these systems to really be used and people not sort of doing vendor-oriented languages, I think we need to sort of looking at how do we approach target? How are we consistently approaching target? Can we define some kind of instructions to users saying that these kind of features are working across the board, so it's safe to use in a large code base, etc., things like that. And also mapping these kind of features towards different types of accelerators.
Okay, so implementation quality more and portable implementation quality questions, if I understand
Absolutely,
correctly.
I think exactly, because if I look back to the early days of OpenMP again, end of 90s, things like that, this was actually something that was quite discussed. So what can I depend on? What aspects of the standard actually does work across the board, right?
That's fair.
Yeah, I'll jump in and echo what Sven said. Yeah, I've seen lots of different papers recently that they're talking about how OpenMP target support varies like across compilers and even like can vary like greatly between like different versions of the same compiler on the same machine on the same code. And just like performance portability problems, where one compiler will like really like maybe a collapse clause on one loop, but hate it on another. But like a different, or let me rephrase that. Like one compiler will like do very well with one set of directives, a different compiler needs different directives to get optimal performance like on the same code, same machine. Yeah, just kind of like remove all of those like fun performance surprises, basically.
That is very interesting. Eric, you want to comment on that?
Yeah, if I can ask a question, do we think that this is a problem with the implementations, or do we think that this is a problem in the spec and definitions?
Both. Partially, some of it's definitely like the implementations are doing things differently, and therefore, yeah, that's definitely going to cause some variations. But also the spec is, I mean, it's definitely still evolving, and like some parts of it are maybe not as precise as they should be, or you know, I'll leave it at that. And
that's totally fair, and you should always feel free to give your compiler vendor of your choosing feedback on those things, because they are usually also involved in the standards committees, and user feedback is very valuable on evolution at that point, right?
I thought it's a multi-level issue. So first, you have to acknowledge the vendor device is different, right? Some with SIMD, some without. So how do you write? I mean GPU. So how to express the pragmas. Then second is the compiler implementation. Because some construct combination was not optimized for certain combination. That just make the performance portability even worse. So it's like just people need to report these bugs or performance issues and communicate and try to improve. That's probably the realistic thing we could do.
Sounds good.
I'd like to make a comment about the implementation. This is Greg. I had conflict, so I had to join this project or the panel session late. But one of the things that I've discovered working on implementations is that the way that we map the hardware to the OpenMP constructs or the OpenMP model. The OpenMP model, let's face it, has 4 levels of parallelism: devices, teams, threads and then lanes for SIMD, right? How we map those concepts to the hardware we've learned can vary, okay? GCC does it one way, LLVM does it a different way. One of the things Johannes and I have talked about is, well, that mapping, that modeling of the hardware to the OpenMP model should be adjustable. In other words, it shouldn't just be one implementation. The implementation should have the ability to change the modeling so that, I mean, I'll be honest, inside a target region for the AMD device on the LLVM, we just ignore the SIMD constructs. we use that. We map the threads to the lanes and we map the teams to work groups. And that's actually just derived from the way that it was done for the NVIDIA or the NVPTX implementation. But I think that going forward, we have to, that modeling of the, mapping the OpenMP model into the hardware doesn't have to be fixed. It can have different mappings. And I think that that's going to affect the portability. If, for example, you had something working well with the GCC OpenMP and you brought that over, well, why shouldn't you have that same model available on the LLVM side so that you can compare apples to apples? Because if you don't have the same model, it could be drastically different, because we're just dropping the SIMD construct. We just ignore it because we're mapping the threads to the different lanes of the GPU. That's the way it is today. We're looking at alternatives to that. So I think the implementation modeling of OpenMP is something that, first of all, should be documented, and then it should also be switchable, right? And I think Johannes would agree with that.
I always do. Maybe one, I give you one thing that I'm looking for that is something that is not OpenMP related and I'm not working on at all. That is the new pass manager. Is anyone here excited that we will switch to the new pass manager, potentially, eventually?
Very excited. Well, I think that makes a lot of sense. It's much easier than the old pass manager. I don't know that everybody has switched to the new pass manager, but a lot of people have moved to the new pass manager. So it would be great if we had a formal, like something in, officially to say the new pass manager is the preferred pass manager for opt.
Yeah, that sounds like a good plan, because we certainly already see features only being there, right? Eric?
Hi, I'm using the new pass manager by default, actually, and my team is one of those that's trying to finish off all the support that we need before we can officially move to the off the old pass manager onto the new one. There are only a few problems left, but some of them are rather sticky. I'd love for any help there, though, especially even identifying issues and identifying problems.
I was about to say there is from time to time people ask for a list of open problems that still exist, things that have to be ported for us to switch over. Do we have something like that?
We do in some cases, and we don't in other cases. I can probably do a little bit of work to get a list and to get that down, and so we have a burn down list, at least on LLVM dev in the next couple of days. Does that seem reasonable?
I think that would be good. A lot of people, like, it pops up every so often that people ask for that, and people are interested having some way of keeping track and actually defining the missing pieces, so we see a roadmap and we see that it is getting closer. That would be great. Anton?
Yeah, I guess the probably the largest bulk of the remaining pieces is all that, I would say, developer side functionality we still have with the legacy pass manager, like all those like printing stuff and some other instrumentation and things like that. Besides that, from the user standpoint, I think it's pretty usable. And as well as Eric, I'm also aware of several out of 3 examples when the new pass manager is used by default in the production compilers, I would say.
Okay.
We've been using it by default for a long while now at this point.
Yeah.
But now the tricky question. But you're still using the old pass manager in the backend, right?
Yes.
So
Yes.
is our plan to kind of support both like pass manager infrastructures because we don't want to port the backend, or do we switch over to default for the middle end and then kind of do the backend later potentially?
So the backends should, and I'm just going to say should, be a simple matter of typing, let's say, to get all of them. I think from a difficulty level of the porting effort, it's much more straightforward and much simpler. It's just that there are a lot of passes in every backend. And this is going to be one of those times where I think we're going to need to see the backend maintainers, especially for the backends that have a large number of passes like x86, like ARM, like Power, really step up and need to start moving their things to use the new pass manager. There's no issue, but the disappointment there is that there will be very little gain to be seen from that, unlike the performance gains of migrating the middle end. But it will enable us to have much better, long-term viability and long-term maintenance issues. So it's one of those that we need to do, and I think we're going to need to rely on the backend maintainers in a lot of ways. But it should be a simple matter of typing if it helps.
Sounds good. I guess eventually, after a few years, we should start to get rid of one of the 2 infrastructures eventually.
I mean, it's only been 7 years that we've been working on this switch. So, how much longer could it be? It'd be nice to get it in under a decade.
Very good. We'll put that in the email to the dev list as the target. Anyone else have a comment, a question? We have officially like another 12 minutes. We could use them.
I have a question that is unrelated to what we discussed so far. It's more about FinLTO and full LTO. So I'm aware that FinLTO is making pretty good progress in giving good performance similar to what we get from full LTO. Is anybody aware of, it's again a case of having 2 different infrastructure to do link time optimization, just like having sort of like 2 pass manager. Can we ever get, is there any plan, or does anybody has any thought about moving to FinLTO and then dropping the full LTO infrastructure altogether?
There's a lot of shared infrastructure there. Thin LTO in a lot of ways builds on top of the full LTO infrastructure. There are only a few differences in pass manager running and a few other things. So I'm not necessarily sure what we would gain as far as long-term maintainability by getting rid of the full LTO pipeline. There's not a lot that we're leaving on the floor within LTO versus full LTO, but there is some small performance, but there's also a lot of scalability in thin LTO that you don't see in full LTO. So
I think we have users that want to have full LTO though. I think it's
Sure.
used actively. So getting rid of it seems like,
I mean, not getting rid of it in terms of, here we go, guys, we're going to remove it without, it's more like a progression. So one of the things that blocks probably full LTO from people want to use it because they still get a little bit of an edge in terms of performance compared to FinLTO, and are willing to pay for the compile time. But I guess as that edge decreases, the difference in performance decreases, then I think a lot of people would be very willing to move to just use one type of LTO infrastructure. And okay, I think was Eric talking, if the infrastructure is common, then there isn't much of an incentive to get rid of one or the other, right? It's just like that depends how much commonality there is between the two.
I think removing the old LTO is less of an interesting question than switching to thin LTO by default, as opposed to no LTO by default, which is what we have now. So I was wondering if anyone is still working on that.
That's largely a lot of build system work and not a lot of compiler work, if that makes any sense. You could try to envision doing that on your link lines, but that still involves build system work. And it's less in the compiler implementation and IR and backend, and more how does your development workflow hook into everything. And I think that also kind of answers the Atari's questions as well, in that the thin LTO involves a lot of build system changes where full LTO doesn't necessarily as much. You can, put everything on one command line and just say go for full LTO. Versus thin LTO, it's a little harder to do that. So I think some of the question is, how do we want to do that, and how do we surface that to users, and how do we combine our efforts with various different build systems, both open and closed source, for everyone.
Yeah, that was nice. It was good. I will like to thank all of our speakers for the day and everyone that participated in the Q&A and open discussion at the end. I really appreciate that. Tomorrow we will start again at 7 a.m. Pacific, when we will have our more industry-heavy talks, where the different vendors that build on top of LLVM give talks about their efforts. We have talks by quite a few, and Greg wants to say something. Greg.
I find with a window that gets me off of mute. Am I off of mute now?
Yes, Greg, I can hear you.
So the real small, quick topic, and I'm not sure if it was covered earlier today, one of the things that we're trying to get done is the switch to OpenMP5, even as the default. And even though not all of the OpenMP5 functionality is there yet, but I was hoping that that would be something that we would see before the fork for LLVM-12. Is there anybody who has opinions on moving to OpenMP5 in LLVM as the default? I'm just, we do have a review up there for it. And when we put it on, very small change, it actually generated a fairly large number of lit failures, and we've been working on those lit fails. We've got it down to like 9 right now because
I think all are solved. Like I think all tests are.
All of them are okay. Yeah.
Yes, I think we.
So, has this been discussed about that? This plan to actually have it put upstream and switch to 5.0 as the default? I guess nobody has opinion on it, so I think there's no negative opinion.
Yes, I think that is the point. So far, we never heard any negative opinion. The features of OpenMP 5.0 are going to be removed in OpenMP 5.1 and have any of those been implemented in Clang. Features that have been removed. There are some minor changes to some features. So 5.1 has, let's call them breaking changes, but minor corrections for features that have not yet been implemented. So to answer this question, literally no and no. but there is minor differences. But we, like a lot of people kind of shoot for OpenMP 5.1 as the kind of next stable thing that will kind of ship out. Also in terms of semantics, because 5.0 had a lot of.
So Jonas, people should look at the document, right? Which is kept up to date on what's changed.
Sure. What document?
The one we maintain for OpenMP checked-in, and also the list of features which are actively being worked on.
Oh, you mean the like implementation wise?
Yeah.
Yes. I was thinking if things change between 5 and 5.1, that is probably in the change notes in the standard.
Yeah, that's what they can look at it. But to know what
yes.
Yeah, what LLVM currently supports, they can look at that.
Alistair asked if there are breaking changes from like basically 4.5 to 5. I guess.
I would say in general, OpenMP does not really introduce breaking changes. That's very, very rare, right? So no.
Would be that's strong.
No, the breaking change would be clarification. We would call it clarification.
Yes, there are changes from 4.5 to 5 that it could break your code, but it shouldn't be as bad as 4 to 4.5. Not nearly, and it's more corner cases that might get affected, but. Yeah, and from 5 to 5.1, there shouldn't be any changes in things that have been implemented. So as long as like you basically couldn't have run it before we kind of changed it to in 5.1. That's the idea. So there were a couple of things we had to correct. Yeah, I'll post a link to the features and.
So one more thing we want to mention is OpenMP is introducing the C++ attributes to express pragma. That's a big change in 5.1.
Okay, so the links are in the chat for the implemented features and the current status, and also the switch to 5.0, in case anyone is interested and take a look. We're at the top of the hour. We had pretty good conversation, and I'm glad we actually filled all of it. And tomorrow we have a lot of good talks, and I hope a lot of you join in tomorrow again to learn what the vendors do with LLVM and what else they add and what they use it for. Thanks again for all the questions. Thanks to the speakers, and I guess I'll see you guys tomorrow.